Hello and welcome, everyone. This is Eliminating Confusion, Virtualization versus Private Cloud, brought to you by Stratascale and Actual Tech Media. My name is David Davis, and I'll be the moderator for today's event. Thanks so much for taking time out of your busy schedule to take 45 minutes to an hour to talk about the differences between virtualization and private cloud today. A few things you should know about the webinar. First off, if you have a question during the event, please use the GoToWebinar questions box there, and we'll be answering those questions at a dedicated Q&A session at the end of the event. We also might answer some of those questions during the event as well. We're going to have a couple quick poll questions during the event, and so we appreciate your participation in those. It helps us to learn a little bit more about you, your environment, and your needs, for this event as well as for future events. We will also be giving away an Amazon $300 gift card to one lucky attendee at the end of the event. So, I hope you'll stay tuned for that. With that, let's go ahead and get started. Briefly, I'd like to tell you a little bit about myself. Again, my name is David M. Davis. I'm a 7-time VMware vExpert. I'm a partner at Actual Tech Media. I've created many training courses at pluralsight.com, and I blog at virtualizationsoftware.com and actualtechmedia.io. And you can find me on Twitter at David M. Davis. And I'm proud to be joined by Mr. James Green and Mr. Jeff Margolis. James, you want to tell us briefly about yourself?
Yeah, sure. Hi, my name is James Green. I'm also a vExpert and partner at Actual Tech Media. I have been an administrator, architect, consultant on the partner and the reseller side, and I do speaking and writing about IT, and happy to be talking about virtualization and private cloud with you guys today.
Yeah, thanks for joining us, James. And we're also joined by Mr. Jeff Margolis, who's the Director of Pre-Sales Engineering at Stratascale. Jeff, what's your background?
Yeah, so thank you for the introduction, not interruption, but yeah, I'm Jeffrey Margolis. I'm based in Chicago when I'm not on an airplane, and I'm the Director of Pre-Sales Engineering for Stratascale. Been here about 15 or 16 months. Previously, I was at Mellanox as a Director of Pre-Sales Engineering for the Western Hemisphere, and I was dealing a lot with cloud and high-performance computing.
Awesome, awesome. Well, we've got a lot to talk about today, so let's go ahead and get started. Before we do, a quick poll question here for the audience, and it's going to be an easy one, and that is, what's the size of your company in terms of number of employees out there? So just curious to get a feel, are there large companies, small companies, medium-sized companies, here on the event today? So it looks like we got a lot of you voting already out there. I appreciate that. With that, let me go ahead and close the results. And as you can see, we got it all over the board. All different sizes of companies, represented on the event today. So we appreciate, you joining us. It's good to have a good mix. And then second quick poll question here is, how many hosts are you managing at your company? Also an easy question. All right, most of the audience has voted. And as you can see, good size to go along with the different size of companies as well. And with that, we'll have a couple more poll questions at the end of the event, but I want to go ahead and kick off the webinar here with today's topics. We're going to talk about virtualization just to kind of set the ground level, of knowledge, make sure we're all on the same plate, because that's what we're doing, is comparing virtualization, to cloud, specifically private cloud. But I want to make sure that everyone's clear on, the numerous forms of cloud, and I want to clear up any, cloudiness, to put out a bad joke out there. We're going to talk about SDDC, or the software-defined data center, and how all that fits in with virtualization and cloud. We'll talk about hyperconvergence and how it fits in, to this big picture of the modern data center. We'll also cover OpenStack, and again, how does it fit in with, cloud, private cloud, software-defined data center, and hyperconvergence? And then Jeff's here to talk to us a little bit about Stratascale and how they help to kind of bring all these together and enable, the modern data center. So first, I'd like to do a little bit of, level setting, as we said, with virtualization. So, what is virtualization? Of course, virtualization, is that abstraction layer. It abstracts away hardware resources, and in the case of server virtualization, allows you to carve up your compute, into multiple virtual machines, which mimics a complete physical server. Of course, there's multiple forms of, virtualization. You can virtualize, the network and the storage as well. So most companies out there, we didn't do a poll on that, but in going around to the user groups and speaking at different events, I usually ask the question, what percentage of your environment have you virtualized today? And there's a wide range of people, all the way from, we're just getting started, all the way up to, a number of hands come up that say we're 100% virtualized. But most companies are, somewhere still out there in the middle. They're trying to get to that, 100% virtualization, but for some reason or another, they just quite haven't. And they also see, cloud and software-defined data center, hyperconvergence, all these different, terms out there that they're constantly being barraged with, and they're kind of trying to figure out, how does all that fit in, and where do we need to go? Do we need to get to 100% virtualization? And I'm sure that causes some confusion. And I hope that's what we, try to clear up today. And feel free to answer questions, or ask questions along the way if we're not being clear, if you're not getting the information you need to help you, see the complete picture here. So benefits of virtualization. It's been really a boon for IT. For more than a decade, it's rewritten the rules of the data center. It's made the lives of admins so much easier. That's my favorite benefit of virtualization. It makes our lives as administrators and managers, so much easier. And it helps us to do things for the business that we were, never able to do before. So in the past, if we needed to deploy a new application in the data center, well, it's going to take us at least a month. We have to spec out the server, the storage, we have to get it ordered, racked and stacked and installed. And virtualization makes us look like we're superheroes, to some degree. But we've also learned, by implementing virtualization, that there's more that we can do. There's overhead that still remains, when it comes to virtualization. We virtualize the compute layer, and it's very efficient. But at most companies, they didn't virtualize the storage. They still have a dedicated SAN or a NAS array there, and they might have a SAN admin or a storage, administration group. So you have that silo to administer, the LUNs and the array and the RAID striping and all that good stuff. Then you still have a networking silo. And so you have a network admin or network, management team, and they have VLANs to worry about, and firewall rules and load balancers and all these, all that networking stuff. And so when it comes to provisioning a new virtual machine, in some cases it might be super easy, just provision a new VM, from a template. But in other cases, with complex applications, there might be a lot to do, and it still might take a week, between all these different teams and silos to get a real, application provisioned. And at many companies, that's still just way too long. It's still it's still inefficient. And that's the overhead, that I'm talking about here. There's, repetitive work still that remains, configurations and the agility and scalability just isn't always there, even if you are 100% virtualized, but you still have these, separate silos, and the users have, no self-service to really provision their own applications or virtual machines. So there's a number of challenges here. And, James, I know you being a vExpert and consultant for many years, I'm curious to learn about, what sort of virtualization challenges have you seen out there, real world, companies?
Yeah, well, you nailed some of the big ones there, David. Over the course of the last decade or so, virtualization has been huge for a lot of companies and significantly changed the way that they do things. But there are still a number of companies that are still trying to get to the 100% virtualized stage you just mentioned. They're because of particular limitations of applications and various workloads that they're running, they're still trying to even get that compute virtualized. But then, like you were talking about, just because of the incompleteness of that abstraction, because we still have storage to provision and network to provision, and there's maybe some manual steps left to the build process. The turnaround time for requested IT services is something that I see and hear about still being quite a challenge. You said a week, and I think for a lot of places that could be even pretty reasonable. There's some places it can take a month, which is something that end users just don't really, that's not what they're expecting of IT anymore. They want it faster than that. And then also as the environment grows, scaling the environments the way that we have been building them in a more traditional virtualized environment can be a challenge. And so we really need to address those things to get both the flexibility of the environment up and the challenges with provisioning services down.
Yeah, great points, James. And I'm betting that there's still a lot of confusion out there, even in traditional IT organizations, between what's virtualization and what's cloud, and because I know there's a ton of confusion in the end users out there. They think they put their Microsoft photos on the internet, and they took their stuff to the cloud, and they expect IT to be able to react just as quickly. Power users or developers know that they can deploy new virtual machines in Azure or Amazon Web Services, in a few clicks in a couple of minutes. And so they really don't understand why is it that IT can't react and respond in the same time frame that they're used to, receiving a new application on their iPhone, or iPad, with a few clicks. Why can't they just do a few clicks at the company at their desk and get the applications they need as well? So I know there's a lot of frustration and confusion out there in the market around that. And I mean, if we talk a little bit now and move from virtualization to cloud misconceptions, I think there's a lot of confusion on what cloud actually is. I mean, people think that cloud is it the internet? If you put things on the internet, is that in the cloud? And that's, as we know, that's not true. Although marketing, consumer marketing especially, they throw that around all the time. If something's virtualized, is it in the cloud? And that's not true either, right? There's a lot more to cloud than just virtualizing, physical servers. And then what about outsourcing? If we were to outsource our applications to somebody else, did we, put that in the cloud? And that's really that's not an infrastructure cloud, at least. So there's a lot of confusion around what is cloud and what isn't cloud. Of course, there's different types of public cloud. I mean, software as a service, SaaS applications. For example, if you use Salesforce.com or many of the ERP applications, are now all being hosted. Oracle, HR, PeopleSoft, all these ERP applications, they're now being offered as software as a service. And so they throw around terms, let's take it to the cloud, and I guess that is really the public cloud. But there's many different forms of public cloud. So you've got these SaaS applications, which is just the application only. You've got platform as a service applications, which are great for development teams, where if they just need access to run a .NET application, or they just need a database that's ready to go right then to store their application data in, it's there for them. There's infrastructure as a service, and that's really what most people in IT infrastructure think about when they think about the cloud. Things like Amazon Web Services EC2 and Azure, and of course VMware's vCloud Air. And then there's so many other different types of X as a service. Companies are offering disaster recovery as a service, and backup as a service, and desktops as a service. And so you see this as a service series kind of continuing across all different forms of applications that can be accessed, or infrastructure that can be accessed within the public cloud. And then there's different types of infrastructure cloud. So, we have my cloud, which, is, let's say, your private cloud. And then we have, the public cloud. So I talked about those different infrastructure as a service solutions. Of course, those are all public cloud, public infrastructure clouds. And then you have private infrastructure clouds. And in my mind, what most companies they might be interested in public infrastructure clouds, but in my mind, my recommendation would be those are only for maybe some very specific types of applications. If you have e-commerce, internet-based applications, websites, massive web development projects. Those are great, for putting those in Amazon Web Services. But for the vast majority of enterprises out there, they have traditional enterprise applications, and most of those are best maintained and looked after by their trusted IT professional teams. But they still need many of the services that the cloud brings, and that's really what private cloud can offer them. And so the other kind of third in the middle form here is connecting your private cloud to the public cloud to make, of course, hybrid cloud. And this almost to me gives companies the best of both worlds. If they could run a private cloud and gain all the benefits that they're looking for, but then, when it comes to some of the scalability challenges or disaster recovery, if they could connect to the public cloud, creating this kind of hybrid cloud and use that for, those specific types of applications where, okay, if they're a retailer at Christmas, they need to burst up, their number of e-commerce servers or retail database servers or whatever it might be. If they need to burst that up, they could do that in the public cloud, or they could run their disaster recovery infrastructure, over in the public cloud in case their, primary data center is destroyed. So, to get from virtualization to private cloud, um, the easiest answer is, well, we take our virtual infrastructure that we have now, with the hypervisor, virtual machines, and applications, and we put this cloud management platform on top, or CMP, and ta-da, we turn virtualization into private cloud. And the easiest answer is yes, that's true. That is how it works. But to kind of have a true cloud, I guess I'll call it, that cloud management platform has to do a number of things. It needs to provide you with on-demand, service provisioning. So the end users or power users or development, directors, whatever, whoever they might be, whoever you determine at your company is the right person, they need to be able to provision new applications, on demand. So that self-service provisioning, they need to be able to have simple and flexible scaling of resources. So they shouldn't have to have LUNs carved up and VLANs configured and so forth to provision those new applications. They should be able to scale up their resources and scale down resources as needed. Of course, we talked about self-service, so provisioning new applications quickly, charging for only the resources consumed, and in a private cloud, that might just mean show back. It doesn't have to mean actually charging back the divisions or the departments that are using those resources, but it's a really great way for IT to justify their massive expense, is to be able to show these business units the resources that are being consumed. And then it needs to support a multi-tenant architecture. So, multiple business divisions or company units or whatever they might be that run securely in their own, environment. They can't, communicate between one another unless you configure that in a secure way. But it needs to support multiple tenants, and those multiple tenants in a private cloud are going to be different business units or departments or divisions. So, James, I'm curious from the companies that you've worked with, and where they've implemented a private cloud, what sort of benefits did you see gained, from them, and how did it change, I guess, the daily life of the organization or the development group or the IT group?
Well, really what it's caused is kind of maturity in some of the problems that we were talking about a little bit earlier on. I was saying that they need to be able to provision services faster. So the private cloud infrastructure that they built allowed them to provision services very rapidly. It also gives them flexibility to meet the needs at a certain point in time. So something you mentioned a little bit ago was maybe a retailer that would scale up and down based on seasonal workloads. customers that I've seen that implemented a true private cloud were able to handle those changing demands on their environment much more easily. And, it kind of moved them into a more modern style of managing their infrastructure. You hear a lot of people using the term DevOps right now. Enabling that sort of culture is something that happens when you implement a true private cloud. And kind of some of the other stuff you talked about here too, multi-tenancy and increased visibility into what's being utilized. And really, I think the biggest thing for any of them is to be able to meet the expectations of their end users. I mentioned a minute ago that there's different expectations on us as IT administrators and directors as far as performance and timeline and that kind of thing than there ever has been. And provisioning private cloud services has kind of allowed us to meet those expectations, which are really challenging.
Right. So like maybe 10 years ago, virtualization kind of made us look like, superheroes in IT. But today it's still cool, but it's not the silver bullet, I guess. It's not the superpower, that it once was, because the bar has been raised. The expectations of the end users and the CXOs, has been raised. And so to me, private cloud, along with software-defined data center, hyperconvergence, all these things we're talking about here, is what's going to allow us to meet or exceed the new bar of IT expectations. So, and then we have this software-defined data center, concept or term. So the SDDC, and in my mind, VMware was the first place that I heard about, the SDDC. But the SDDC isn't a VMware-only thing, although they might, kind of tout it as such. It's a general concept of, running your entire data center abstracted away from physical hardware, devices that are designed for a specific function, running your entire data center, compute, storage, and networking in software. So, you've got software-defined compute, which the virtualization, the hypervisor, essentially provides us. Software-defined storage, which hyperconvergence, which we'll talk about in just a second, provides us. And then software-defined networking, which there are a number of different, SDN solutions out there today. And by bringing all these together, all these different software-defined compute, storage, and networking, you have, essentially achieved the software-defined data center once you put, cloud management and automation on top of that to kind of bring it all together. So in my mind, that's the software-defined data center, that everyone needs to try to get to. That's the general concept there. And, virtualization is just one piece of it. Private cloud with the cloud management platform, is another piece of it. But software-defined storage and software-defined networking are still two very important pieces that doesn't, that you don't necessarily have if you have private cloud and if you have virtualization. So this is kind of starting to bring it all together here. Hyperconvergence, though, is another very important piece. So, with HCI or hyperconverged infrastructure, you're essentially using software-defined storage technologies, to distribute the storage resources across your compute layer. And so you're able to eliminate your physical NAS or SAN, distribute the storage across this, software-defined storage layer, and with hyperconvergence, kind of bring it all together into a single point of management. So you have software-defined compute or virtualization and software-defined storage all being managed in a single place. And that's the general concept with hyperconverged infrastructure, and different companies and different solutions, kind of package this in different ways. But James, I'm curious, how would you say that hyperconverged infrastructure fits into the private cloud vision, and what's your experience or take on hyperconvergence?
Well, both SDDC and hyperconverged infrastructure are really about removing some of the limitations that we talked about in between just virtualization and private cloud. And so, in my mind, SDDC and HCI are really about enabling private cloud by providing, in the case of SDDC, flexibility and scalability. One of the big challenges with scaling is swapping in and out pieces of hardware, and because you outgrow hardware or hardware becomes end of life or that kind of thing. And so SDDC really handles the ability to continue provisioning services regardless of what's happening with the physical hardware. And then hyperconverged solves some challenges around things like scalability, also around some of the availability while you're changing hardware, but particularly around scalability. For instance, if the workload is growing, hyperconvergence allows us to just pop a couple more nodes into that cluster and suddenly meet the needs. And it's much simpler than re-architecting the entire infrastructure based on the growing needs. And so the customers that I've seen do that have had a lot of success in their journey from virtualization to private cloud.
Right. Yeah, I get what you're saying there. I mean, I think what you're alluding to is the IT life cycle. I think so many IT pros are just consumed with the IT hardware and software, maintenance and upgrade life cycle. So, provisioning new servers, updating those servers, decommissioning those servers, whether it's, and the same thing goes for software, operating systems and applications. Um, I know as an IT manager, I felt like we spent, at least 25% of our time just keeping everything current. And that's especially true in the case of, a dedicated SAN that is in most cases the most, single complex and expensive piece of infrastructure in the entire data center. And, everything relies on it, and you purchase it for a 5-year term or whatever it might be. And so replacing that and scaling that and managing that is a huge waste of resources, I guess you could say. And so software-defined storage allows us to eliminate that inefficiency, if you will, and scale our infrastructure up and down, along with the compute layer and along with the needs of the applications. So hyperconvergence, the outcomes that companies are looking for is, simplified procurement. So as we talked about with the IT lifecycle and the SAN, it's easier, like James said, to add new appliances to your data center and scale up your compute and storage at the same time. It's easier to deploy, new applications because everything's packaged in, say, a cluster of 3 appliances or whatever it might be. Simplified operations, you manage it from a single interface, both the compute, and the storage, and sometimes the networking as well. And then you have that simplified scalability where you can add more appliances as your storage demands increase or your application demands increase. And then another piece of this puzzle is OpenStack. So OpenStack is an open source project started by Rackspace and NASA that has just exploded over time in terms of its popularity and the number of companies that are contributing to all these projects that make up the OpenStack cloud management platform. And so the diagram on the right shows many of the different packages that are included. And OpenStack, provides that open source cloud management platform. And some companies have tried to implement OpenStack themselves. But I've talked to a number of those companies and read about them, and usually it takes some real technical people who have spare time to learn OpenStack, to compile things, to look at source code, to run scripts, and a lot of kind of do-it-yourselfers might be able to do that if they have the time and the resources, or if the company is willing to hire a team of people. But in many cases, the learning curve, for OpenStack, and then the constant maintenance, and integration is just too much at this point, I think, for a lot of companies. And that's why they're looking for solutions that make OpenStack easier. That's my take. And what I'm hoping for, or what I believe that the vision for the future should be, is kind of a coming together of all these different technologies. So at the bottom you have your physical servers, network, CPU, storage, and on top of that you've got your software-defined data center with hyperconvergence. So software-defined compute, storage, and networking. And then you've got your virtualization layers where you can run virtual machines, and then yes, even containers in alongside your virtual machines, because I believe containers are really the virtual machine of the future. And then on top of that, a cloud management platform such as OpenStack, which has really kind of become the leader in the space to kind of bring it all together. And then you would be able to scale this data center of the future, and pool all your resources together. Add the cloud management platform on top. Again, using software-defined storage, networking, and compute, the whole SDDC kind of suite to really enable the business to become more agile, to scale their infrastructure up and down, and to meet the needs of their employees and the needs of the business. So, I mean, that's kind of my take on how all of this fits together. James, if you don't mind me asking you a question out of the blue, what's your take on the diagram you see there on the screen? How do you see all this fitting together?
Yeah, well, like you mentioned, OpenStack has grown and is continuing to grow into a very robust solution. But like you pointed out, it's still, frankly, hard. Other cloud management platforms that have been around were hard. OpenStack is hard, and frankly, there's not one that I'm aware of that's not hard. And so I think the vision for how this will happen in practice is spot on, and I think really what we need is, at least at this point in the life cycle of cloud management platforms, is we need somebody to come along and kind of wrap their IP around this whole vision to make it easier for us, because there are a number of companies that I've spoken to out there who tried it and gave up just because it was consuming so much of their time and effort. And I think that they would have really benefited from having gone through with it if they had the tools to enable them to do it successfully.
Yeah, yeah, well said. I think there was a blog post recently that was spread around the internet. It was about Netflix and their adoption of cloud, computing, and something about how it took, them 5 years to do, and it was entitled, "Cloud is hard," and and that kind of underscores, the difficulty. But like you said, the vision is solid, and what companies really need is someone who can help them to kind of bring this all together, which is why I invited Stratascale on the event today, and I'm glad that Jeff is here to talk to us a little bit about the Stratascale vision and what they can do and how they can help companies to make this vision a reality. Jeff, are you there?
Hi. Oh, excuse me. Yes, I am. If you could jump into my first slide, that would be a benefit. So I'm going to probably be covering some of the things that you guys already covered up until now, and I appreciate you did a great job. But I wanted to augment and potentially add a couple of complementary things as well. So when we're talking about cloud, cloud can mean one of three things in terms of what is being provided. For example, what Stratascale is providing at this point is really more infrastructure as a service, and we'll show you the architecture in coming slides. Of course, on top of that, software as a service or platform as a service can also be run on top of a Stratascale infrastructure. And as you said before, software as a service is a cloud offering like a Salesforce or a WebEx or any of the so-called web applications. And then platforms allow customers to develop new things where they don't have to be totally aware of what's happening underneath. We can provide that as well, but that they can have sort of an injection point for creating very robust applications without having to worry about where it's hosted, your power ping and pipe, or what's happening underneath. They can provide anything to their customers, start up new companies, and these kinds of things as well. So what I also like to explain to my customers is virtualization can be done in the cloud, and you can also have bare metal in the cloud, you can have containers in the cloud, but it's not necessarily the opposite, where just because you have virtualization means that you have a cloud in your environment. An example is I have a Fortune 500 company who has a very robust virtualization environment of tons of nodes, but when they want to deploy any kind of applications, those applications have to be tested in a different environment. There has to be change management that has to take place. They have to file cases to get the new virtual machines up and running. They have to worry about all different types of levels of red tape and bureaucracy to get an application deployed in a virtualized environment. But even if they would like to rapidly test, write, deploy, tear down, change, or do anything in that virtualization environment does not make it a cloud. So let's skip on to the next slide. So again, what Stratoscale is providing is a very, very simplified way of deploying a very complex infrastructure as a service deployment. We are giving all of the resource pooling, multi-tenancy, self-service, and automation within our system. The way that we do this is by providing an entirely encapsulated software deployment that runs on any of the hardware that a customer might have already in their environment. So for example, if you're running HP and Lenovo servers, Dell and Supermicro servers, any of these kinds of pieces of hardware in your environment, we will lay on top of that and plug into any of the networking systems that you already have. And then what happens is as you add more nodes into your cluster that is the Stratoscale Symphony deployment. Symphony is the name of our product. As you start to deploy more and more of these nodes, they cluster together automatically and give you everything that you would need for a cloud. So yes, we're providing virtualization, but we're adding all of the different layers like multi-tenancy, self-service, automation, and resource pooling on top of it. Next slide. So as an example, what we see very often in the news today is that people are moving from a public cloud to deploy their entire company's system. This is very much the way the Netflix model works. They're 100% public. What's always fun to hear is that some of Netflix infrastructure is running on their own hardware in their own data centers, and a lot of it is bursting directly into Amazon Web Services from that like 6 to 10 o'clock hour when people are watching any of the shows that are being provided by Netflix. And what's happened on the other side is that companies like Groupon, which is based here in Chicago, have deployed a lot in the cloud, and it's gotten to a point where it's getting to be too expensive, and they have the capability and they have the infrastructure available to bring everything back in-house for the ability to have control and security over what their offering is there to provide. Next slide. So what are customers expecting from a private cloud that, once again, is fit and fiddle with what Symphony, our product, provides? It's plug and play. We are giving a single pane of glass for operational and regular ongoing use of self-service. There are migration tools to come from public clouds, from other places within your own infrastructure. We can bring in VMware virtual machines, again, so we can interact with VMware environments, with virtualization environments. It's enterprise grade, so this is running on all of the big iron metal that is already in your environment. There is the ability to upgrade the Symphony cluster by bolting more nodes on of any size and shape. Blade servers, 2U servers, HP, IBM, Dell, Supermicro, Lenovo, any of these guys, Cisco, UCS, they can all run within the same cluster to provide the cloud environment. It's highly available, and there's security. There's a lot of issues in a public cloud when you're starting to throw your data out to a provider that you don't have control over, save your ability to pay the bill every month. And it's cost effective. So if you need to deploy your own private cloud, this can be an expensive situation where you're buying tons of brand new hardware. You are bringing in experts to try and implement an OpenStack distribution, because trying to implement OpenStack isn't simple out of the box. So we make it very simple and have the ability to pay as you grow. We can run on commodity hardware, and we recognize that operating systems and applications of today tend to be pretty greedy in terms of CPU and memory usage as well as network. So we provide a just-in-time situation where those resources are given to the operating systems and applications as needed, but we kind of fool them into believing they still have them. When they're not being used, we bring them back and give those to other applications and operating systems in the environment. So we're giving an optimal hardware utilization within this private cloud situation. Next slide. So this is what the Stratoscale Symphony architecture looks like. It's very interesting. So if we're starting from the very bottom here, what we provide is the software-only hyperconverged architecture. So the other players in the hyperconverged market are providing these very expensive appliances where you have to layer a virtualization license on top of that, and that is not cost-effective at all. We can see that buying just a couple of nodes in a hyper-converged market could be hundreds of thousands of dollars, and that is not the goal of bringing a less expensive but very robust environment. So again, say you are trying to deploy a brand new private cloud running Stratoscale Symphony. The way this is done is any kind of server from any OEM and any size and shape, as I said, blades all the way up to 4Us or anything in between, and as long as the CPU microarchitecture and newer, Sandy Bridge and newer, then you can coexist tons of different servers and continue to bolt on those devices to expand on your cloud. So let's say, as an example, I have 3 Cisco UCS servers, I install Symphony, and I want to add more storage and compute and so forth. What I can do is bolt on an HP server, a Lenovo server, any kind of new things that are coming out, from that being a Sandy Bridge CPU all the way up to a Skylake CPU in the same cluster. So we're scaling just as you start to locate more infrastructure and want to grow it as you move along. So on top of that, you install the Symphony operating system. We bring all of those nodes into a majorly useful resource pool. We virtualize all of the networking. So you go to your single pane of glass and create all of your layer 2 through layer 4 network requirements for your customers or for your in-house customers, whether those be development teams or whatnot. We virtualize all of the storage and create a software-defined storage solution where we take all of the disks inside the cluster. So if you have 10 servers and 10 disks, we have 100 disks that are now in a big block storage device. We provide all of the virtualization that's required. And then we bring this in a very resilient cluster situation. We give you resource load balancing, multi-tenancy, and tons of monitoring and analytics such that you can do capacity planning and choose when you want to add just another disk drive to increase the storage, or just another stick of RAM to add more memory, or another network adapter. So you can sort of micro scale or macro scale as you move along. And then, of course, we give you a control panel that's web-based, so no need to install a thick client like an executable on Windows. This will run on a tablet or a laptop or a phone or whatever you have out there. And we also provide APIs, those being OpenStack APIs, Stratoscale APIs, REST APIs, and so forth. And this gives us out-of-box capability to integrate with third parties for security appliances, network appliances, various applications that are pre-built that are coming from third parties. So we're not an OpenStack distribution, to be clear, but we provide all of the OpenStack APIs for the projects for which we are working with. These would be Cinder for storage, Neutron for networking, Nova for compute, Keystone for identity management, Glance for image management. Next slide. Let's skip forward. I think I've talked a little bit about this as well. Yeah, keep going a little bit more. Okay, so again, bring your own hardware into a Symphony cluster. Any x86 server and all of the x86 servers, so long as the oldest CPU microarchitecture is Sandy Bridge and newer. So this is Sandy Bridge, Ivy Bridge, Broadwell, Haswell, Skylake, and anything that comes out in the future. Right now, we don't have AMD support. We have heterogeneous hardware configurations, so we detect all of the various types of hardware that you have out there and allow you to create your clusters based on any type of heterogeneous configuration. And you can start very small as 3 nodes and as large as hundreds of nodes. And there are no dedicated nodes the way that we have designed this. So it's a horizontal scale out. So the way that our architecture works, there's no network node, there's no storage node, there's no management node, there's no compute node. Everybody is participating in all of the services and create a mesh in terms of the management plane. So this creates a very robust and very resilient architecture. Next slide. So our compute is based on a cloud-optimized KVM. KVM is very nice when you install it out of any old plain Linux, but we've created our KVM implementation to be cluster aware and to be aware of all of the other subsystems that we have. So the hypervisor is aware of what is happening on the storage, networking, management plane, and so forth. And the reason we do this is it makes KVM more intelligent, and we have a resource scheduler that allows the workloads on our cluster to be placed around so they can be providing the most robust experience to the person who is using that or the team that is using that workload. We also, again, remove some of the overhead that is inherent in these applications by doing memory deduplication and compression. So what this does is make sure that as much as a developer or an application wants to grab onto memory, if it's not being used at that particular moment, or we see a lot of redundancy in the memory pages, we will reduce that, which will allow, again, to save some hardware costs by allowing you to pack more virtual machines into a single physical server based on reducing that overhead. Next slide. Okay, and storage, again, we started to talk about this, and it's a very interesting deployment. So what we do, again, is we take the disks inside of the servers that are running in the cluster, and we create a block striping for very fast performance. It's a configurable data protection using replication. Essentially what this means is as you create your cloud, you can start to separate the disks into pools and say, I want these pools to have 0 replicas, it's scratch data, up to multiple replicas. So if we lose a node on purpose or power outage or whatever, that one node won't take any of the storage features or storage accessibility to any of the workloads. We have an unlimited amount of volume snapshots, so if you would like to move forward or backwards in a snapshot situation, we provide that as well. And everything that you see here can be done by command line, API, or web interface. We're also the only hyper-converged / cloud provider that will allow you to take any external storage and also integrate that into our clusters. So if you already have very expensive external storage for which you have a sunk cost and you already have data residing on that, and you want it to be a part of your private cloud, no problem, plug it into your servers, install a couple of drivers, configure a pool, and you're off and running, as well as, and lastly, is integrated disaster recovery. So multiple sites can be completely available in the case that there is an outage in an entire facility. As far as our networking is concerned, we've created a very robust networking feature set. We are providing all of the layer 2 through 4 networking services. This includes, as a subset or example, firewalls, load balancers, security groups, VLANs, IP, DHCP, and so forth. When we install a cluster, we do an automatic node detection. You can bring a 4-node cluster up in less than an hour, and it'd be completely up and running, and we're doing all of the configuration of the networking, storage, and so on and so forth. And we have very flexible network configurations from multiple 1 gig links all the way up to 10, 40, and 100 gigabit Ethernet links as well. From a cluster management perspective, we have a centralized control system, but everything is distributed in terms of the processes that are running the cluster itself. What that means is I go to one virtual IP address that accesses all the APIs, web interface, command line, and so forth, but all of the services that are running the cluster are completely distributed. So if you lose a node to a power outage or maintenance mode or whatever, the services that are running on that node are relocated to other nodes throughout the cluster. This provides for a service that is very self-healing and load balances all the services. And it's an enterprise-grade software upgrade system that is ongoing because we're constantly doing continuous integration to make sure you have the latest code available in your cluster. Now, again, about our cluster management, what we see in the hyperconverged market is that a lot of the intellectual property of those vendors is running inside a virtual machine, and those virtual machines are taking up tons of resources, in which case it's adding latency and performance just to do management. All of our resources are running sort of a kernel space or user space outside of VMs, but fully integrated and fully distributed throughout the system. This causes very low overhead and very low impact to your workloads. We want to give all the I/O for CPU, memory, network, and disk back to the user and not take it for our own purposes. And when we start to see that certain nodes are overloaded or require any kind of load balancing, we have a robust load balancing scheme, and this works out into two separate scenarios. Number one is when we introduce workloads into the cluster, we're very intelligent about knowing what's happening throughout the system, and we can place workloads where we see that they would best be fit. And then if we see a certain amount of workloads become noisy or become overtaxing to a particular node, we'll migrate those workloads from source to destination in less than a second. So we do the workload profiling and we do the dynamic load balancing, not just when the CPU is going up, but when CPU, memory, disk, network, or anything else is causing other virtual machines to have resources that are starved. Again, we're providing all of the APIs that you could ever want to consume to use this in a DevOps environment as a use case example. We're OpenStack powered. This is a certification by the OpenStack.org committees, and it gives us an out-of-box simple integration with any third-party OpenStack plugins. This means, again, if you're buying appliances or applications, management planes, monitoring, so on and so forth, based on OpenStack, then they can integrate with us out of the box. And this is happening with tons of vendors out there today. Our user interface is continuously delivered, so you might be looking at a user interface at the end of the day one day, leave and come back the next day, and you'll see all of this new information, all of these new features that are being upgraded at a constant basis without touching your running cluster. This gives us tag-based analytics, rich diagnostic tools, OVA migration, and heads-up display for your network operations center. So just some use cases, and by no stretch of the means is this a limiting situation, but we have a ton of customers that are already in the dev test environment, DevOps, big data, disaster recovery, remote branch office. They're using us as a private cloud, and we have service providers that you might be using today that are giving a privately labeled public cloud experience running on Stratoscale. Again, if you're interested in OpenStack but you don't want to pay for what it costs in time, money, and expertise, we can give you that OpenStack experience without the pain and suffering of using OpenStack. And again, we're the only vendor out there today, and I'll say asterisk that I know of, that is providing the ability to add on internal or external storage as you guys see fit. Next. So just a little bit of a Stratoscale Symphony benefit summary right here. And just to take 1 second, if anybody has questions, comments, concerns, thoughts, or hurrahs, I have the easiest email in the world. It's jeff@stratoscale.com. Feel free to email me, and we can talk about anything more. But we are a single stack that gives you compute, storage, networking, control, and management, fast and easy to deploy. This can go from 0 to cloud in a few hours or less, scaling from 3 to hundreds of nodes. We're hardware agnostic. We're not shipping appliances. We're not overcharging you for hardware. That can be left to whoever you're working with. We have very ease of use management. If you want to get into the OpenStack world, we have a great injection point for that. Or if not, you don't want to see, or touch, feel, think, or smell OpenStack. You can use everything by web and command line based on our own APIs. We have a very nice total cost of ownership based on delivering this as a subscription service, so you pay for what you need and no need for any third-party licenses, so you don't buy a hyper-converged infrastructure and then go back and pay VMware for more. And then we have optimal resource utilization, which is based on policy-driven placement and the memory optimization, so you can have a very dense VM environment.
All right, excellent, Jeff. Excellent presentation. We have a few minutes left here for Q&A, but first I want to do just a couple quick poll questions of the audience. And while those poll questions are up, maybe I can ask Jeff some of these questions that have come in. So the first poll question here is, what's your time frame for implementing a private cloud? And I'll just leave that up. Jeff, if you don't mind taking a couple questions. First one here is, what's the typical migration path for someone? If today they're running, the most common hypervisor out there, they've got, a bunch of servers, maybe a SAN, how do they get to a Stratoscale solution?
So there's multiple options, one of which is we have our own import tool, and it comes with the product. By the way, there is, no paying for support or features. It's all in the subscription, meaning you do pay for it, but it's in the subscription cost. We don't separate out any feature or support whatsoever. So with our product, we give you a migration tool that can implement the import of any virtualization platform that exists today. VMware, Hyper-V, Xen, KVM, whatever you want, you can implement this and implement all of the resources directly into our cluster.
Okay. And let's see, another question here is, I think there might still be a little confusion based on this question on what exactly is the Stratoscale offering. Am I clear? It's software only, and
Yep.
it provides software-defined compute, essentially hypervisor, virtualization.
Yep.
It provides software-defined storage, so hyperconvergence.
Yep.
It provides software-defined networking, which is very unique in the hyperconvergence world.
Yep.
And then it provides the cloud management platform in the form of OpenStack.
I think that the best way to kind of explain it is that if you want a private cloud and you have some brand new hardware coming in or 2 or 3 year old hardware laying around, you can create a cloud in about, let's say, 10 to 20 minutes per server.
Okay, nice. That's a good way to put it. I like that. Let's see. Let me bring up another poll question here. While we are taking a few more questions here from the audience. So it's subscription based, so that includes support, and it's licensed. How's it licensed, Jeff?
So it is per server per month annualized. So it is so you pay a certain amount per server per month, and then I believe that you work with your channel reseller in acquiring it, or your OEM. We do not sell direct, and this allows you to get the software. We also provide free versions for you to test and play with, or do POCs, or get a feel for it.
Okay, awesome. And what's the best way for them to try it out?
So they can email me, jeff@stratoscale.com, or you can sign up for a trial directly on our website.
Awesome. Let me announce the winner. I know everyone's waiting for this as well. The winner of the $300 Amazon gift card is Charles Schumer. We will be contacting you via email to deliver your gift card. Congratulations. So if you have any more questions, feel free to put them in the Q&A now, but we are quickly running out of time. For more information on stratoscale.com and for a free trial, please visit stratoscale.com and check it out. Jeff, anything you'd like to add?
Please, by all means, if anybody has questions or anything they would like to ask me or argue with me about, jeff@stratoscale.com.
Awesome. Well, we'll be getting to these other questions via email after the event. Again, great questions, great audience attendance today, and great presentation. Thanks very much, Jeff. And thanks, everyone. Have a great day. Bye-bye.